Hello. Today we will discuss about conduction current and displacement. So let me just start with conduction current first. Then we will talk about displacement current. Then we will try to have a mathematical expression for the conduction current, displacement current. And finally we will going to compare what is the idea about the conduction current and what is the idea about the displacement current. A simple difference and or the comparison. So let's start. So what is conduction current? In very simple way one can say, when you have flow of electrons or flow of charges, the current produced because of flow of charges is known as the conduction. A simple picture given over there. We are considering two words. In one case we are applying direct current, a constant directional voltage was applied, and now here you have in the right hand side you have alternating current. Same voltage you are applying, but the polarity is changed. Now what we are going to do? We are going to consider a unit cross sectional. A unit cross sectional area we are going to consider. The radius of this circle is unit, 1 unit. Here also you have 1. So how many number of electrons are we are going to calculate? So if the number is 6.24 into 10 to the power 18 number of electrons are passing per second, then we are going to consider this is as 1 ampere. So this is the idea about the conduction. Normally it happens that conduction current is passing through the conducting materials. Now the next one, you have the displacement. Displacement current is basically is a concept of electromagnetism, which represents the changing electric field in the non-conducting material, mainly because of non-conducting material and because of changing time dependent electric fields applied over there. We get it. Time varying. The simple idea about this one is a capacitor. So what is the basic structure of a capacitor? There will be metal plates. These black lines are representing metal plates, and in between there will be dielectric. Now the dielectric material they are basically good bad conductors. They are having some atoms. At the center there will be nucleus and electrons are placed surrounding. Now when there is no external field, the atoms will retain their shape. But when you apply a field, the shape of the atom will be disturbed. So how they are disturbing? A simple picture is representing. Now this capacitor, this side is positively charged and this side is negative. So for that case, when you apply this is positive and negative, now see the positive part is attracted towards negative and the negative part of the electrons will attracted towards the positive. Now so the shape of the atom will be disturbed and they are forming a dipole. So two polarities are there, separate polarities. Not only this thing, now if you connect it with a alternative current, alternative source, so the polarities will change continuously. This is positive and negative. After some time, this will be negative, this will be. So the whole part will be now oriented in the opposite. Now this particular picture is explained. I mean, one direction the applied field is this, and in another case applied field is in this. So now you can see the dipoles. The orientation of dipoles are just reversed. So they are continuously changing depending on the frequency of this applied field. So due to this, so there will be flow of current within the bad conducting or within the non-conducting. Now here in this case, free electrons are not carrying electric field. Rather, inside the non-conducting material, the time varying electric field helps us to pass the electric field from one to another, from one plate to another. Now this was explained by Maxwell's equation, famous 4 Maxwell. What is Maxwell equation? There are 4 Maxwell's equation. The first one is because of electrostatic, which is known as the, it is explaining the flux of electrons. Then the next one is for the magnetic. So here magnetic flux was explained. Third one is the Faraday's law. So Faraday's law, it was talked about a change in electric field in space is because of change in magnetic field in time. Now, the last one is the Ampere's law, or sometimes we used to call the Ampere's law, modified Ampere's law by Maxwell. So, actually, the Ampere's law is up to this particular point, where it shows that curl of magnetic field, that means the space dependent magnetic field, space variation of magnetic field is proportional to current or the current density. Now this is applicable for JC. What is JC? JC is IC divided by unit cross sectional area. So we are considering a unit cross sectional area. So how many number of electrons are passing? This is known as the current density. Now, if you have a circuit where you have a resistor and you are connecting with the alternative current, okay. Now, if you are talking about the magnetic field of this particular thing, then this equation is valid. But if you just connect a capacitor with this, with having some dielectric material inside, now through this red region, you will get IC or JC in the system. But within the blue region, we need to know about ID or JD. Now, this is represented by this particular. Maxwell added this part, which explains the time-dependent electric field, or sometimes used to call as I. Current due to displacement. Now, what is this Ampere's law? Just mention this thing that integral over magnetic field is because of which current? JC or IC, whatever you are touching. And the next part, if you have a capacitor, now you need to add this particular. Here it was phi E, that means electric flux. And electric flux is time dependent. And this is because of JD or ID if you are not considering. If you add this to, so normally in a capacitor, in a circuit, electrical circuit, there will be resistor, capacitor, inductor, number of components are available. So in a particular circuit, there will be both effect, conduction effect and the displacement effect. So simple equation is now the left hand side of the equation is a one-dimensional integration. As we are talking about flux or current density, we are talking about two-dimensional. So the left hand side is one-dimensional and right hand side is two-dimensional. So how to overcome this problem? Then we can use the Stokes theorem. The Stokes theorem convert one-dimensional integral into two-dimensional. So when you are converting this thing, this will become curl of magnet. Now both sides are surface integral, or both sides 2D integral, left hand side and right. So just rewriting this one, we get the expression. So the last part is the conduction part, and the first one here, this is because of the time dependent electric field or the displacement. Now we have considered a simple circuit having resistor and capacitor, voltage applied, current passing through this I1. Here this is. In simple way one can say what is I1. I1 simply given as V by R, simple Ohm's law. Now this I1 is basically the conduction. So here electrons are flowing, and for that case one can get electric field, one can get current in the system. Next part, we are talking about current densities. What is current density? Current per unit cross sectional area. A is denoting the cross section. This is given as sigma. Now, sometimes it is called the Ampere's law, generalized form of amperes. This is because of the movement of. Now the next part, we have this capacitor. Okay, I2 current is passing because of the applied. What happens there? How to write it? So I2, this is equal to C dV. Okay, so time dependent. Remember, you have a time dependent electric field. What is C? What is the capacitance value? So the capacitance value is given as epsilon A divided by A. What is this thing? You can take a capacitor, that means you have two conducting plates, and in between this there will be a dielectric plate. So the cross-sectional area as represented by A. What is the cross-sectional area of the plates is given by A. And distance between the plates is given by D. The distance between the two plates is given by A. So if you have this one, and if you have certain dielectric materials placed inside this thing, so the capacitance value is given by this. And epsilon represents the field strength or dielectric strength of this particular material. For two different dielectric material, epsilon values will be different. Now we have this. So you are just rewriting capacitor value. Okay. Now the next one. Now you know what is electric field. Electric field is equal to V by D. D is the distance between the two plates. It's a dimension, it's a linear dimension. Okay. So V can be written as electric field into D. Just put this thing in this equation. Where we can put this thing in this particular equation. So when you're putting it back, so this simply gives you epsilon A by D dV dt. So what is V? V is given as E into D. Okay. So now this D, the first D in this equation, first D is equal to, it's an operator. But this D representing is the dimension. Now as you have D, it's a constant term, and here you also have a D. So this to D will be, yes. What is left? Epsilon A dE. Okay. So this is ID. So ID by cross-sectional area, this is GT. So now you have epsilon A by A. So now again A and A will be adjusted. So what is left with? Left with epsilon E. Epsilon into E. So epsilon into E is represented by capital. This is a vector. This is the applied electric field, and here D is the displacement because of the time dependent field. So JD is given as DT, the time dependent D1. Now you have JC and JD, both terms are there. JC and JD. What is total current? This is JC plus. Now the most important part is that in certain material JC is prominent, in certain material JD is prominent. But there are certain materials available, both JC and JD. So where JC is prominent, where JD is prominent, you can check. Now for that we are considering, so we have applied some electric field, exponential I omega. So what is exponential? Normally when you talk about current, time dependent current, we are representing it by sine omega plus some, or instead of sine, you used to consider some cos. But if you know e to the power I theta or plus minus I theta, this is given as cos theta plus minus I theta, cos component and sine component. So a alternative current which was represented in terms of sine and cos, this is basically generalized form of a exponentially applied electric field. Now when you have this one, you can differentiate this. And you can find the ratio between JC and Q. This is given by current. Now when JC will be greater, if this particular ratio is greater than 1, particular ratio is greater than, then JC will be prominent. But if this particular factor is less than 1, so obviously JC will be less than JC. Check it when this will happen. This happens when this is greater than 1, and this is the case of a perfect conductor or a good conductor. So in good conducting material, this is greater than, this factor is greater than So JC will be greater than JD. Okay. So the majority of the current because of the flow of charges, electrons. And in the second case, what you have this is less than 1. If this is less than 1, this is the case of a perfect dielectric, perfect that conducting material which are able to produce the dipole signal inside the system. So obviously this is less than 1. If it is less than 1, JC is less than JD. So the majority of the current is because of the distance. But in physical world, certain materials are available. They are not very good conductor, not even very bad conductor. So in this case, both JC and JDs are available up to a certain. Now, an important question is, you have a resistor, you have a capacitor inside the system, current is flowing. So now, the question is whether they are two different types of current or finally they are giving you a same amount. So to explain this one, we are considering the capacitor. Okay. Simply we are considering a plate. Another plate we are considering. Here the dimension of the plate is A and the distance between the plates. And we are placing some dielectric. So for that case, when you apply that electric field, say one side is positive charge, another side is negative charge, so they will form the dipole. Okay. If you change the polarity, the negative it becomes positive, so again the polarity will be different. So for that case, the amount of charge inside the system is given by this. So what is Q? The amount of charge is C into the voltage applied. Okay. Now you know electric field is equal to V by T, this term, and also you know this particular relation we have already mentioned. So what is ID? Displacement current is a displacement field at a time. Okay. Actually, when you are integrating over ds, okay, this basically gives you the cross-sectional area, total cross-section. So one can simply rewrite this is divided by A. I am taking it A over there, and it's a continuously integrated over this. So A is, what is D? D is epsilon E. Suppose this value epsilon. Let me just check this, rewrite this. So here epsilon, okay, epsilon. Now as we are integrating over ds, this gives you A, so we can write it A. Epsilon A, and electric field is given by V by D, so we are having D over there and V. So epsilon A by D dV. What is epsilon A by D? This is capacity. So this becomes C into dV. Now C is a constant term, so we are taking it inside the operator. So d dt over C into V. What is C into V? It's just total number of charges inside the capacitor. So this becomes dq dt. Now the question is, what is dq dt? The rate of change of charges. Okay, and obviously this is current. So which type of current is this? So one can say IC is equal to IT. Now the last part of this one is a simple comparison or difference between conduction current and displacement. So the most important part is conduction current is because of the flow of electrons. Remember this thing, flow of electrons because of the appliance. Now here in this case is the displacement. Now this is the rate of change of electric. How this will change? The rate of change is electric field as a function of time. Okay. Now conduction current, it is produced due to the flow of charge carriers. This type of charge carrier electrons uniformly, whereas the electric field is constant with time. Okay. But here this is produced due to the movement of electrons with the rate of change of electric field, the time dependent. Obviously, we are talking about the flow of electron, that voltage is proportional to current. So, voltage is proportional to current, it comes from the simple Ohm's law. But here, as we don't have a flow of charges, you have, because of the electric field, time dependent electric field, the orientations of dipole is changing. So current is passing, but this is not following. As it is following Ohm's law, this relation is simple. V and I is proportional, and there will be R, constant value, depending on the material. And what is ID? This is epsilon d phi dt. It's a flux. Okay, so how many number of charges? How many number of lines of it? It represents the actual current, but it represents the apparent current produced due to electric field, which is time. Thank you.